All right, hi everybody. It's about 11 o'clock. We should get started. In terms of announcements and stuff off the top today, of course, it's our last class of the semester. There's no lectures next week during finals week. I just wanted to confirm that for you. I'll post an announcement on Canvas about what my office hours will be next week and stuff like that. But feel free to contact me while you're preparing final exam stuff if you want to go over your quizzes or any other stuff that you're thinking about. And also, one person emailed me about a good question. I have the chapter 10 quiz marked as being due today, just because it's our last class. But if you need to turn that in late, feel free. Just get it in before the final exam if you need a little bit of time to digest this chapter. And you'll have to finish reading it on your own, because I almost certainly won't get through the whole thing. Let's see. I guess that's about it. So we can get started. As usual, I'm just going to very quickly flip through what we covered last class, first of all, just to remind you of where we were. So last class was all about kind of summarizing the science of what is global warming all about. First of all, just understanding what is going on. So I talked a little bit about my sources. Don't forget about the IPCC and the Berkeley Earth Project if you ever want to research this on your own. We talked about what global warming is, which is just simply an observation that the temperature of the Earth has been going up. It's been going up since 1950, since 1850, since 1750, and it's gone up around 1 degree Celsius to 1.5 degrees Celsius. Sea level has also been rising. And then the explanation for why this is occurring is that the amount of energy that's arriving at the Earth from the sun is greater than the amount of energy that's leaving the Earth and escaping into outer space. And the reason why we think this is the case is that the energy that arrives at the Earth is in the form of visible light, and the energy that leaves the Earth is in the form of infrared light. And greenhouse gases are these gases in the atmosphere that allow the visible light to pass through, but don't allow the infrared light to pass through. So they end up trapping in some of the energy that comes from the sun. And then the more greenhouse gases you have in the atmosphere, the higher the temperature of the planet would be expected to be. And the main greenhouse gas that people talk about is carbon dioxide. Okay, carbon dioxide, most importantly, is emitted by burning of fossil fuels. And in the chat, someone's just asking about the chapter 10 quiz. Yeah, feel free to do the chapter 10 quiz late. I won't deduct points as long as it's in by the time I do the grades. And they are extra credit, the chapter 10 materials, because you'll have to do some reading on your own to prepare for those. Okay. So then I built up this story about the evidence of why we think that the greenhouse effect is the right explanation. So first of all, we know that we're emitting a huge amount of carbon dioxide into the atmosphere because of fossil fuel use. That's something we can measure. We know that the amount of carbon dioxide in the atmosphere has been going up because that's also something we can measure. We know that those two things have been going up hand in hand with each other. So that seems to be correlated. We also know that carbon dioxide levels are way above any level that we would expect from just natural up and down fluctuations of the carbon dioxide level. So it does seem to be something that's not a natural effect that happens frequently. We also know that the temperature tends to go up when the carbon dioxide level goes up, which is consistent with what we would expect from greenhouse effect. And we also know that the other most likely explanation for this would be that the amount of energy that we're receiving for the sun could be going up, but that doesn't look like it's the case either. So that leaves us with the greenhouse effect as being the main reason why the temperature of the Earth has been going up. And we got into this little side story, which I won't review, about the Berkeley Earth Project and so on. So then the final conclusion is atmospheric concentrations of carbon dioxide and other greenhouse gases are at the highest levels of at least the last 800,000 years. And we believe that their effect, together with those of other man-made effects, are extremely likely, which means at least 95% likely to be the main cause of the warming that we've seen, at least since the mid-20th century, if not further back than that. So, and then I very quickly went through this section about some of the possible consequences. And that leads us into today's discussion, which is going to be about some of the more practical questions. First of all, once you accept the fact that global warming is a problem, the next most obvious question to ask is, well, how do we solve this problem? And there's a few different ways we need to address that. First, we need to actually address the question of, what does it even mean to solve global warming? If you picture a world where global warming has already been solved, what are you picturing? What actually is the final situation that we're working towards? And then are we on track to actually achieve that solution, or how long is it going to take us to achieve that solution? How much warming are we actually expecting to occur before this problem gets solved? And then a second dimension of this that comes up a lot in very practical things like international agreements and people's political views and things like that, is which countries are contributing the most to the problem. And therefore, you know, the implication of that is, well, which countries should be doing the most in terms of trying to solve it? And I'll do what I can to give you some information about those issues. All right, so first of all, what is our goal? Why don't we start there? What should be our goal? I told you earlier in the chapter that the amount of warming we've had so far is, let's call it 1 degree Celsius, or maybe a little bit more than 1 degree Celsius. And like I said last class, that amount of warming is not too much. It's a very manageable level, which is why there haven't really been any really catastrophic effects from global warming so far. But one really important question is, how long do we have to solve this problem? How much warming is too much? Which is a hard question to answer, but the question that kind of answer that's been arrived at, the scientific community says that basically 1.5 degrees Celsius of warming should be our goal. That once we get beyond 1.5 degrees Celsius of warming, the situation starts to get much more serious. And if we miss that goal, the backup goal is 2 degrees Celsius. Once we hit 2 degrees Celsius of warming, that's where things start to get very serious. In the words of the IPCC report, future climate-related risks depend on the rate, peak, and duration of warming. So it's not quite as simple as I'm making it. But in the aggregate, those effects are larger if global warming exceeds 1.5 degrees Celsius, and especially if the peak is high, about 2 degrees Celsius. So just to confirm to you that those two numbers, 1.5 degrees Celsius and 2 degrees Celsius, are the two goals that people are usually talking about when they talk about like what our goal should be. 1.5 degrees Celsius is kind of the more ambitious goal, and 2 degrees Celsius is kind of the, well, hopefully we can at least keep it below that level. Okay, so that's our goal. Now, what are we actually on track for based on what's happening so far? How long do we have to solve the problem? And when are we actually going to fail to meet those goals? So here's a graph of the temperature of the Earth from the Berkeley Earth Project over the past century plus. And what you can see is that since 1980, the warming of the Earth has actually been very consistent. That's this section of the graph here. You can see how the red line is very clearly increasing at an almost constant rate. And that rate is the temperature of the Earth is going up by about 0.2 degrees Celsius per decade. Okay, so how long does that give us? Well, you can see it's marked in the chart here. At this rate, we're going to hit the 1.5 degrees Celsius goal in the 2030s, and we'll hit the 2 degrees Celsius goal in the 2060s. So this is not something that we have a lot of time to work on. we are going to fail to meet these goals actually pretty soon, especially the 1.5 degrees Celsius goal. So this is not something, this is a problem that we've kind of been kicking the can down the road for the last several decades. And now we're finally getting to the point where there's no room to kick the can down the road anymore because the deadlines are here. You know, we've procrastinated and procrastinated, and now, you know, the assignment is due tomorrow. We're about to hit these goals. And again, here's the Berkeley Earth project in words, that the temperature will reach 1.5 degrees Celsius by about 2035 or so, and 2 degrees Celsius by about 2065 or so. So those are kind of like our deadlines of when we will fail if we don't improve. Okay. Let's go to the IPCC report version for a minute. So again, 1.5 degrees Celsius would be pretty good. 2 degrees Celsius is kind of a failure. What are we headed for as of now, if you kind of project this forward? If we don't do anything and we just allow everything to evolve and just completely ignore the problem, what we're expecting is to have about 4 to 5 degrees Celsius of warming by 2100, with additional warming after that, by the way. So if we don't address this problem, we are going to wildly overshoot these marks. So we're not even close to achieving that, just, you know, if we don't make any effort. But of course, we are making some effort. So how are things going with the effort that we're making? If we say that what we've done so far is enough, we don't need to implement any additional restrictions. We're just going to continue with what we've done so far. We would be expecting about 3 to 4 degrees Celsius of warming by 2100, which is still wildly missing the mark. So definitely we need to do significantly more than what we've done so far. If all of the countries in the world actually succeed in everything that they promised to do in the Paris agreements, we're expecting about 2 or 3 degrees Celsius of warming by 2100. So actually, even if every country in the world follows through with everything that they've promised to do so far, we're actually even still going to miss the 2 degrees Celsius mark, most likely, although we'll at least be close to it. So you can see that we have some problems right now. We have some serious problems right now, that the rate that we're going has been totally unsatisfactory in terms of actually solving this problem in a timely way, with the level of, you know, aggression that we actually have to have in order to solve it in time. In the words of the IPCC report, pathways reflecting current nationally stated mitigation ambitions until 2030, which basically means in the Paris agreements, are broadly consistent with cost-effective pathways that result in global warming of about 3 degrees Celsius by 2100. And by the way, with additional warming taking place in the 22nd century. This is all just until 2100. We're not even addressing what happens after 2100. So the Paris agreements were an important step forward. The Paris agreements, by the way, if you're not too familiar with this world, that's where finally, after many years of discussion, just about every country in the world got together and actually made some concrete promises to start reducing their greenhouse gas emissions. So if everyone follows through on those promises, we're actually still not on track to meet our goals, but we're somewhat close. So I don't know if that's encouraging or depressing. Depends how you look at it. We have made a lot of progress over the last few years, but the progress we've made has been not really the level of progress that we need to make in order to solve the problem. According to the IPCC report, they have a good quote here that there are multiple mitigation pathways that are likely to limit warming below 2 degrees Celsius relative to pre-industrial levels. So in other words, there is hope that we can meet these targets. It is possible. We have analyzed a number of different scenarios of how we might handle this. And there are scenarios where we do meet the 2 degrees Celsius mark. However, these pathways would require substantial emissions reductions over the next few decades, not in the distant future, but actually over the next few decades. And they would require near zero emissions of carbon dioxide and other long-lived greenhouse gases by the end of the century. So in other words, in order to actually make the goals that we've set for ourselves, we have to make substantial progress over the next couple of decades, and we have to basically be completely off of fossil fuels by the end of this century, which is, a tough thing to imagine happening so quickly, but that's what we have. That's the situation we're in right now. Here's another nice little chart I found in a recent news article. It shows here the black line is labeled as historical emissions. So that's what we've done so far to date. And then this news article, they consider 3 different scenarios. Scenario 1 is this blue, and that is if we just keep our current climate change policies worldwide, and everyone just keeps doing what they're doing now. They don't get worse, they don't get better. And what they end up estimating is about 3 degrees Celsius of warming, like I said earlier. And then they have an optimistic scenario in purple, which the optimistic scenario assumes, you can see down in the fine print here, it assumes that basically everyone in the world will actually follow through with the promises they've made to date. And that results in about 2 degrees Celsius of warming. And what we would actually need to do to meet our goals is this green scenario, which is, way below the other ones, especially in the near term, way below the other ones. Because, in the world of politics, it's a lot easier for people to make promises that we're going to make progress over the next 50 years than it is to say that we're actually going to do something right now. So that's one of the big distinctions is to really meet the 1.5 degrees Celsius mark, especially, things need to start happening like right now. There's really no time to wait. And that's where you can see the green one to meet 1.5 degrees Celsius starts going down like within the next few years. So that's the kind of situation that we really need to be working towards. In the words of the more recent IPCC report, pathways limiting global warming to 1.5 degrees Celsius would require rapid and far-reaching transitions in energy, land, urban and infrastructure, including transport and buildings, and industrial systems. These system transitions are unprecedented in terms of scale and imply deep emissions reductions in all sectors. So in other words, to meet our 1.5 degrees Celsius goal, we need to change everything we're doing in all sectors and make deep cuts, which the scale of which is completely unprecedented. So is it possible that we could achieve 1.5 degrees Celsius? Yes, but we would have to do things, change things on a scale which is completely unprecedented in history. So it's a little bit hard to actually imagine that being achieved. But we can still say that it's at least possible. Now, the next question you might have listening to this is, why is the situation so bad? Why isn't this an easier problem to fix? And there's a really, really basic and very, very important to understand point about this that a lot of people gloss over. And I think even a lot of people who would consider themselves well-informed about this topic really misunderstand. It's a subtle point, but an important one. And that is, what determines the amount of global warming we have is not what we're doing right now. What determines the amount of warming we have is the cumulative total of everything that's happened since the beginning of the Industrial Revolution, basically. And so the situation then becomes, the longer you wait to start implementing solutions, the less of a margin you have for actually implementing those solutions. Because every year that we don't make cuts means the cuts that have to be made in the future are even worse and even more severe. Because even if we cut down to zero, instantly, we would still have a warm world. We would still have global warming. The global warming doesn't just go away when we get rid of fossil fuels. All that means is that the warming won't continue accelerating and getting even hotter and hotter and hotter. So that's a big problem, which makes the solutions that we actually have to implement much more drastic than what you might think. And it also means that putting things off is much more difficult than you might think. In the words of the IPCC report, cumulative emissions of carbon dioxide, not present emissions, but cumulative emissions, largely determine global mean surface warming. Multiple lines of evidence indicate a strong, consistent, and almost linear relationship between cumulative carbon dioxide emissions and projected global temperatures to the year 2100. Okay, so that's a key point. Another facet of that key point that people misunderstand a lot of times is, because it's cumulative emissions that matter, when you picture what does a solution to global warming look like, the solution must necessarily be completely getting rid of greenhouse gas emissions, because just reducing emissions actually doesn't solve the problem. Because if we reduce emissions, all that does is slows the rate that warming is happening, slows how many degrees it's going up every year. But if you want it to start going up 0 degrees per year, you have to not put any greenhouse gases into the atmosphere, so that you're not continuing to pile and pile and pile onto the problem. So even making deep cuts to greenhouse gas emissions doesn't solve the problem. What we're working towards is actually net zero greenhouse gas emissions, which basically means essentially not being able to use fossil fuels at all, in not even the distant future really, but this century, completely stopping the use of fossil fuels. Okay. And if you then start looking at, well, what's been going on so far, what you notice is, in spite of all the talk, in spite of all the international agreements, in spite of all the people who kind of care about this issue, the amount of greenhouse gas emissions worldwide just keeps going up and up and up and up and up. And remember now, again, our goal is not to get this graph to stop going up. Our goal is actually to turn it over, get it to start going down, and get it all the way down to 0. So we haven't really even succeeded yet in stopping it from rising. And then we have to start decreasing it and getting it all the way down to 0. Now, the one recent exception to this is, I actually updated, if you're following along with the PowerPoint that's on the Canvas page, I changed out this graph just this morning because I wanted to get an updated graph that included the effect of the COVID pandemic. And that's that's kind of the one exception. You can see this little dip, or this little weird feature at the very end. And that's coming from when everything shut down earlier this year, and greenhouse gas emissions fell quite a bit. But you can see how much they fell. I mean, I don't know if this is really, again, I don't know if this is, if you want to be optimistic or pessimistic about this, if it's encouraging or depressing. It's encouraging that for the first time, there has been a significant decrease in greenhouse gas emissions. But then on the pessimistic end, it's actually not that big of a decrease. We only went back down to 10-year ago type levels. And also it bounced right back to just a little bit lower than it was before. It spikes downwards, but then it bounces back to about here. I don't know how well you can see that on your screen. But so the actual net decrease for 2020 is probably something like 5%, 10% decrease, which is nice. It's nice that we have a decrease, but you know, we have quite a bit to go, even with that event decreasing emissions a little bit more than was expected. Another aspect of this to understand, which kind of makes the situation even more depressing, is that even, let's say that, okay, let's say that we do have a chance to solve this problem. So let's say we do successfully solve the problem. We do start making progress. We cut our fossil fuel emissions all the way down to zero. One thing you need to understand is once we go down to zero emissions, global warming does not go away. It just doesn't get any worse once we reach that point. And the amount of warming that we're at that time, that's where we then are for the next few centuries. Because it takes the time scale for the temperature to naturally start going back to normal is a time scale of like several centuries, because these things happen on like geological time scales. So what you should be expecting is that many aspects of climate change and associated impacts will continue for centuries, even after man-made emissions of greenhouse gases are completely stopped. Temperatures will remain approximately constant and at elevated levels for many centuries after a complete cessation of man-made carbon dioxide emissions. So that makes the situation even more serious, that this really isn't a problem that can be solved after the fact. It has to be prevented. That's the only way the problem can be solved, is by preventing it. It's incredibly difficult to remove carbon dioxide from the air once it's there. It's so much easier not to emit it in the first place, but it requires us to act before the situation becomes really bad. And that's the situation that we're in right now. I got a question in the chat of how can we expect overpopulated and poor third world countries to move from fossil fuels when presently they are not equipped to do so, which is a great question. This is actually something that I'll address momentarily. How can we expect poor countries to actually make the transition to zero emissions? Economically, we probably can't. Ethically, we probably can't. But the reality is that they have to somehow, because that's the only solution to the problem, which has created a lot of tension, especially amongst kind of more environmentally oriented, like leftist groups, where they want to solve global warming, but they also don't want to create, you know, poverty and economic hardship in a lot of countries. But the reality is that if you don't have any demands for poor third world countries to cut their emissions, you cannot solve this problem. It is impossible, because so many emissions are coming from all over the world. But then I'm getting a little bit ahead of myself. I'll show you in a few minutes where are the emissions actually coming from worldwide, and who is emitting, and which countries need to address this problem. So this is actually a question that I will answer much more carefully in probably 20 minutes from now. So let me come back to that question. Okay. I then have a few slides here about, sometimes at this point in the presentation, people will start asking me questions about, well, isn't it possible that we could actually use technology to remove carbon dioxide from the air? And if you think about it that way, maybe we don't have to have actual, like, maybe we don't have to switch completely off of fossil fuels, because we could just use fossil fuels while simultaneously removing that carbon from the air using some kind of technology. And that kind of technology is called carbon dioxide removal technology, not surprisingly. So there are technologies that can remove carbon dioxide from the air. And this is, of course, something which is being very actively and feverishly researched right now. But the short answer to the question is, we don't really have any good ways of doing this right now. We can do it a little bit, but not on a large enough scale to really make that much of a difference. And it's also incredibly expensive to do it. So the bottom line is, can we remove some carbon from the air? Yes, but not very much. And removing the carbon from the air is much more expensive than not putting it there in the first place, economically speaking. Also, another part of that answer that I want to emphasize is all of the estimates that I've been giving you of how much warming we're going to have, those estimates are already assuming that we're going to do that we're going to keep pursuing carbon dioxide removal. And that is built into those estimates already, the amount that we can decrease the temperature using technology. But we can only really plan on decreasing the temperature by maybe, according to the quote I have on the screen right now, we can maybe decrease temperature by, let's say, 0.2 degrees Celsius using technology, which is insignificant compared to the amount of warming that we're actually causing. In particular, when we talked about the possibility that we might actually reach the 1.5 degrees Celsius mark, that assumes that we're going to be removing about 100 to 1,000 billion tons of carbon dioxide from the air in the 21st century, which we currently do not really know how to do, but we're working on that technology right now, and that is already built in to what I told you earlier. Another interesting quote from the IPCC is that reversing warming after an overshoot of just 0.2 degrees Celsius during this century would require upscaling and deployment of carbon dioxide removal at rates and volumes that simply might not be achievable. So again, like if you're thinking about carbon dioxide removal, think about that as maybe helping for a fraction of a degree and buying us a little bit of extra time. But you can't count on this technology to like completely save us and decrease the temperature by multiple degrees Celsius or anything like that. That's crazy talk. I'm just going to skip through these slides here just to save time. But if you want a little bit more detail of what carbon dioxide removal might look like, I have some details here that I'll just flip through. So if carbon dioxide removal is not really the solution to this problem, then what is the solution? And the answer is what they call in this business mitigation efforts. And mitigation is another important piece of jargon when you read about global warming. Mitigation simply means not emitting the carbon dioxide into the air in the first place. So mitigation includes things like not using fossil fuels anymore. Mitigation is easier to achieve than carbon dioxide removal, and it's also cheaper to implement than carbon dioxide removal. The only downside of mitigation is that it has to be done before the problem actually occurs. It has to be done beforehand. We can't wait until it becomes a catastrophe, because then mitigation will be too late, and our only option would be carbon dioxide removal. And again, quoting the IPCC report, without additional mitigation efforts beyond those in place today, and even with adaptation, remember adaptation means things like carbon dioxide removal that protect us from the effect of global warming. Warming by the end of the 21st century will lead to very high risk of severe, widespread, and irreversible impacts globally. Okay. So that's kind of the depressing part of today's presentation. The next question that's probably on your mind is, well, we have all these looming, very serious problems. What are we supposed to do about it? And that's kind of going to be the rest of the class today, is different ways of answering that question. The first one I want to talk about here is, what can you, listening to this right now, personally do to reduce the amount of global warming that's occurring because of you? And then after this, we'll talk about the more bigger question of like, well, what can our country do? What can the whole world in general do? And these kinds of questions. But let's start with the small scale. What can you personally do? There's a big section in the 1.5 degrees Celsius report about this. And they actually identify a list of what are the most important things to do, which, in their words, have the most pronounced synergies and the lowest number of trade-offs. And what they mean by that is that basically these are solutions which they have big positive impacts and they don't really have a lot of negative side effects associated with them, which some solutions to global warming have problems associated with them as well. But so these are like things that can actually be easily implemented, which have big positive impacts. And those things are, according to the IPCC, number one, lowering energy demand. I'll talk about each one of these in detail in a second. Number two, lowering our amount of material consumption, less consumerism, basically. And number three, lowering the greenhouse gas intensity of the food we eat, changing our diets. So let me mention in a little bit more detail what each of those three things mean. So first of all, energy demand. That one's pretty obvious. One of our biggest causes of fossil fuel use is electricity and other energy use. Electricity, heating, cars, all that type of technology that uses energy. So we have to, number one, reduce the amount of energy that we use. And number two, make sure that the energy we do use is coming from something other than fossil fuels. So that is actually easy to do on an everyday level in a lot of different ways. Number one, you can reduce the amount of energy you use in many different ways, which I won't get into in the presentation today, really. You can probably figure this out for yourself, different ways that you waste energy. We talked a little bit in chapter 6 about where we actually use energy and how you can calculate how much energy you're using and all these types of things. But remember from chapter 6 that the biggest ways we use energy are heating and air conditioning and refrigeration. So cutting back on those things by doing stuff like insulating your home properly, because you're just literally burning energy to no effect. If you have, you're allowing a drafty home to just waste heat and waste air conditioning in the summer and things like that. So properly insulating your home, doing different solutions that will reduce the amount of energy you're using, switching from drying your clothes with a clothes dryer to hanging them up, maybe, not using as much hot water, all these kinds of mundane solutions that people are always talking about in the environmentalism world. One very even more important solution is, though, maybe let's say you can even get your energy bill down 50% by doing all these different things. There's still 50% left, right? So an even better solution, really, or an even at least more effective solution, is to make sure that the energy you are using is not coming from fossil fuels as much as possible. And now that's something that in Pennsylvania is actually really easy to do, because we are one of the states in America that now allows you to choose your electricity supplier. So you actually have a choice. If you pay your own electricity bill, you have a choice of whether your electricity is coming from fossil fuels or not, because you can go online, look at a list of energy suppliers, and choose who you want to generate your electricity. And you can choose any number of different suppliers, like the one that I have on screen right now, which will use 100% renewable energy. Like this one I found, I just went on the Energy Choice website and took a screenshot of one of them. This supplier does 99% wind turbines and 1% solar panels. And that's where your electricity is coming from. So even if you don't cut down your electricity usage, at least it's coming from non-greenhouse gas sources. Of course, in Pennsylvania, you probably have natural gas for your heat. So you'd still be using fossil fuels for your heating, but at least you won't be using it for other things. So I wanted to highlight it just because it's a choice that you can literally implement in a matter of 5 minutes. That'll have, really significantly reduce the amount of greenhouse gases you're personally putting out. All of the different fossil fuels do produce greenhouse gas emissions. The biggest offender is coal, but also oil products, including gasoline, are on that list. So like switching to an electric car is a good solution as well. Natural gas doesn't produce as much greenhouse gas emissions as other fossil fuels, but it does produce still a significant amount. So getting away from that as well if possible. But anyway, you can probably fill in the blanks here yourself of all the different ways that you can reduce the amount of fossil fuels that you're using. So that was number one on the list, reducing the amount of energy you use and making sure that the energy you use is not coming from fossil fuels. Number two on the list was reducing material consumption. And what that is basically referring to is that everything that you buy, whether that is clothing, whether that is a phone, whether that is a bottle of shampoo, whether that is, anything, produces greenhouse gases because of how it's made, because it takes energy to make it, and it takes all these different things that happen in the background, transportation, et cetera, et cetera, et cetera. All of these things go into a greenhouse gas footprint for what you use. So if you're doing something like frequently buying these fast fashion clothes that you wear for a year and then get rid of and buy something new, that actually has a huge greenhouse gas footprint. So what we need to do personally and as a society is figure out ways of getting away from this traditional, people in this business call it a linear economy. A linear economy refers to the idea that we make something, we sell it to someone, they use it, and then they throw it away. And by the way, I am not talking here about recycling being good, because recycling doesn't really help that much, frankly. It's better than throwing something away, but it's minimally helpful. So this includes buying something, using it, and then recycling it. Also is still a linear economy. What we need to switch over to is we make something, we sell it to someone, and they basically use it forever in some way. Now, depending on what industry you're talking about, using it forever could take different forms. It might mean that you, instead of, like, the simple example would be like, instead of using a roll of paper towels, you have a rag that you wipe the counter with, and then you wash it and you use it again and again and again and again and again, over and over again, instead of using something that's meant to be thrown away when you're done with it. Or, in the case of your phone, this can take the form of, the model we have right now is manufacture a phone, sell it to you. We know that you're only going to use that phone for a couple years, and then you're going to throw it out and buy a new phone. That's a linear thinking. It should be structured in a way where you buy a phone, and if it's obsolete in a couple years, they need to provide you with a way to repair it, maintain it, upgrade it, etc., so that you can keep that same, even if it gets updated or whatever, you keep the same physical object and keep on using it. So this ties into a lot of different things. It ties into the right to repair fight, of allowing consumers to, and encouraging consumers to repair their products instead of buying new ones. It goes into how things are manufactured, that they should be manufactured to last forever instead of this kind of planned obsolescence idea. And it also factors into the concept of having disposable packaging on products, where you put the product in some packaging, and we all know going in that that packaging is going to get thrown out. Well, why do we put it in packaging that's meant to be thrown away? Why don't we have it in another method? And to give you an example of that, there's a lot of interesting solutions coming in right now. Like, let me play this little video I found online. I don't know where this video is coming from. I forgot. This is somewhere in Europe, obviously. It's not in English, but this is a dispenser at this grocery store where, instead of buying, the example you'll see in the video when I play it here is dish soap. Instead of buying a bottle of dish soap, using it, throwing the bottle away, and buying a new bottle of dish soap, I take my empty bottle to the grocery store and fill it back up and then use it again, because there's no reason why I have to buy a new bottle every single time I buy dish soap. That's stupid. I should just be reusing the same bottle every time. It's the same as like a reusable water bottle, instead of buying a plastic water bottle that gets thrown away every time. So that's an example of like things that we take for granted of linear economies, that we have all these things that we just are made to be thrown away, which that idea needs to go away. And to this topic, I invited a little guest speaker to break things up for a few minutes today. This is, you might be able to see he's taking off his, he's turning on his camera right now, Petros. And he actually runs a company that's kind of similar to what I was just showing in the animation there, of a company based out of Boston, which allows you to kind of like get your items refilled and to reuse the packaging instead of throwing it away all the time. So I'm interested to hear in how a business like this works, and some of the problems they encounter, and how we can get, you know, more businesses like this around the United States, and just hear what he has to say. So I invited him in here to tell us for a few minutes about what his company does and how it works, and then we'll do a little Q&A if people want to know a little bit more about what he's talking about. So I switched off my screen share, so let me turn it over to him, and we'll hear what he has to say.
Awesome. Well, thank you for having me. So first of all, I'm going to spend a lot of my time talking about that kind of number two, the how can we personally reduce our material consumption, and specifically moving from that linear economy, as Michael put it, to a more circular one. And so more than anything, what I hope to get out of this, or what I hope you get out of this, is the fact that there are practical solutions to combating global warming. And more than anything, I'm going to kind of focus on a somewhat tangential issue, but really kind of a heavily correlated issue of plastic waste, and kind of how our recycling system has broken down and frankly has contributed a lot to our greenhouse gas problem. So as Michael had alluded to, I have started a company called Good Filling, which is a refiller of home care and personal care products. And so the same way that in that video, you had an individual walking into a store to refill their kind of dish soap or shampoo or multi-surface spray, essentially I'm enabling folks in kind of the Boston community to do the same thing. And more than anything, kind of with the goal of moving from a system of kind of recycling or throwing out to a system of kind of reducing. So moving from that linear economy down to a more circular one. And so if you think about kind of the environment that exists today for most of these products, the more than likely solution, or at least the one that's kind of most common today, is to walk into your local CVS or to your local pharmacy and to physically purchase a new bottle with every single purchase. Obviously, kind of correlating with that is the manufacturing of the plastic itself, the freight and transit of the bottle itself, ultimately kind of your use of it, and then kind of throwing it out or hopefully recycling. There's been a lot of focus over the last kind of 20 years, more so on kind of the recycling effort. And one of the things that I really wanted to spend some time talking about is just kind of in what ways that kind of recycling effort has actually broken down, and in what ways it's actually somewhat correlated with this greenhouse gas issue that we have. And so one of the things that you have to think about is kind of from beginning to end of kind of the plastic life cycle and kind of the recycling life cycle. And there are kind of a couple stats that maybe will help kind of frame up this conversation. So the first being that about 40% of all plastics that are manufactured are intended for single use. And then the second stat being that about 99% of plastics are only used one time, despite this fact that about 40% or that other 60% are intended for multiple use. And so if you think about the life cycle and kind of the system that exists, there's really some kind of practical ways to solve around it. But today, kind of the life cycle goes from the manufacturing of the plastic bottle, transporting it to your local CVS, you picking it up there, using the product, ultimately, let's say you recycle it. So taking kind of the right approach. The reality is that a lot of the kind of recycling that you're putting in there isn't actually making it to any recycling facilities. And so there's a couple issues there. So the first one being this concept of kind of wish cycling, and this idea that more than likely along with your recycling, there are products that actually can't be recycled. And so as those products are picked up by your ultimate recycling company or whoever's kind of running it in your local communities, it's being taken to a facility that ultimately sorts the plastics and sorts the papers and sorts the cardboard. It's then bundled up with other plastics and kind of transported to another facility that's actually able to kind of physically melt it down or physically recycle it. The reality is that a lot of these kind of recycling facilities are based in countries like China or developing countries, which I know kind of gets into Michael's next section of kind of developing countries versus developed countries and kind of where does the issue lie and who's the right person to solve it. But the reality is that the majority of our plastics are actually purchased from China. And so not only are they first bundled in the United States into kind of like these bundles of plastic, but they're then shipped to China. Once they're in China, oftentimes these bundles are actually ultimately incinerated because they have various greases or various compounds within them that doesn't actually allow for the recycling. And so that kind of wish cycling of throwing away a greasy cardboard box and introducing grease to the recycling is actually kind of limiting the amount that ultimately makes it. So that's issue number one. And then kind of issue number two is kind of now that it's in China, not only does everything have to be kind of melted down, which kind of in and of itself is producing some greenhouse gases, albeit kind of less because there's not that kind of virgin extraction of the materials itself. But it ultimately needs to be shipped back to the United States, which is creating kind of greenhouse gases in and of itself. And so more than anything, kind of going back to the original issue and the idea behind kind of good filling is kind of turning that system on its head. And what if we could operate under an environment in which kind of we can actually reuse our products rather than needing to rely on this kind of broken recycling system that exists in the United States today? And so to the extent that we can enable folks to reuse their plastics rather than ultimately recycling them, we're ultimately kind of bettering the environment and hopefully kind of preventing the addition of more greenhouse gases. So hopefully that's kind of an intro to the idea. I wanted to save some time for kind of more Q&A to the extent people want to talk about the issue, talk about kind of what we're doing at Good Filling, or just talk about the recycling problem in general.
Anybody have questions they want to ask?
I had a question.
Sure.
So I often get into this argument with my mom a lot about washing our recyclables because I do know that that is an issue with the grease. But she insists that like there are facilities here that actually wash the plastic before they get compacted to be shipped off or something like that. I don't know if that even exists, but I'm wondering if you have any knowledge of that. Like, are there places within the U.S. that actually filter things to make sure that the quality of the plastic can be recycled?
Yeah, so there's kind of two portions of that issue. So one being kind of what compound is physically being mixed in and whether or not it can actually be taken out. So actually, ironically, kind of soaps and soap substances wouldn't need to be washed out versus certain oils and greases would need to be washed out. And the rationale there being is soaps actually help to clean the plastic itself. And so if you throw out an empty soap bottle, the fact that it gets mixed into the recycling and actually helps other plastics to then be broken down versus things like a greasy cardboard box or food or peanut butter on the inside of kind of a plastic bottle. The oils that are involved are actually making other plastics dirty, which ultimately results in other plastics not making it into the recycling system. So that's issue one. Issue two, just being kind of the cost associated with actually cleaning the plastics. And so one of the things that kind of really flipped everything in my head was the fact that recycling is a market. People are physically buying plastics. For a long time, China was actually paying municipalities in the United States to collect their plastic. This is totally flipped in the last 2 or 3 years, in that we are actually paying China to take our plastics off of our hand over the last 2 or 3 years because they haven't been able to keep up with the plastic demand. And so as you think about it in terms of like an economy, one of the big things is like, to the extent that a manufacturer or an individual collecting these plastics actually needs to go through and clean the plastics, it's just an additional cost and an additional step in process, step in the process for them to go through. and therefore is contributing kind of both to cost, but also to the ability to actually go and recycle certain products. So hopefully that answers your question. I think point being is generally, to the extent you can clean a product at home, you definitely should before recycling it. But there are certain compounds where it actually might be beneficial to leave it in your recycling.
Thank you.
Yeah, also, by the way, the rules for how you're supposed to wash things and stuff like that, that's all on the website of whoever picks up your trash. Like for me, it's the city of Philadelphia. And a lot of people don't really look at those rules, but it'll tell you exactly what you can recycle, what you can't, what you should wash. You are supposed to wash the stuff in Philadelphia. And they have those rules that they don't explain, but like one of the common rules people ignore is you shouldn't throw away greasy pizza boxes in the recycling because they can't get the grease out and then it ruins the whole batch, just like Petros is talking about.
Yeah, I saw one question in the chat. How have you been able to grow your business? And so this is really kind of where I'm trying to bring the practicality to a broader issue. And so if you think about kind of solutions today, specifically for refilling, one of the kind of big things that's kind of inhibiting the ability to refill is either shipping or kind of rent or retail space. And so at least in kind of the Boston community, there are not too many refillers out there. Our two primary methods for kind of getting our products refilled are to either order online, so buying like a 1 gallon jug of something from Amazon or from Puracy or from kind of one of these kind of refilling networks, in which case there's kind of cardboard associated with it, plastic associated with it, freight associated with it, all to ultimately get it into my home. So not a very practical solution. And then the second option being kind of these more retail-like refillers. And so out in like Cambridge or Brookline, people are setting up stores for people to walk into, not too dissimilar from that video, where people are walking into a store to ultimately get their products refilled. The issue there being rent is really expensive and it's really pushing people outside of the city. And so more than anything, I want to kind of bring some of the benefits to the city. And so that's really brought me to kind of another portion of innovation that kind of my company has been trying to bring, which is really setting up these more localized outposts and trying to reduce our overall footprint and our overall cost structure. And so essentially what we've been doing is we create these like locker systems that are spread all throughout the city. And so we have about 8 lockers spread all throughout the Boston area that essentially just enables people to drop off their plastic bottles for us to ultimately pick up, refill, and then return back to those locker systems. So it doesn't have that retail presence and it doesn't have that shipping issue of sending things to individualized places in cardboard boxes with plastic waste. And so that's really been kind of the key to our success, is trying to reduce the operational costs while also kind of adding to the convenience factor of individuals and bringing it to those localized settings.
So you actually refill the same bottle and give it back to them, as opposed to like taking the empty and giving them a different bottle, like with propane tanks or something?
Yeah, so we actually are more of that propane tank model, where it's essentially like a bottle sharing service of sorts, where individuals will drop off their empty bottle in our facility while simultaneously picking up a new one. And so from that aspect, they're getting a bottle within 24 hours of kind of purchasing it without needing to go to the store 2 times. And so essentially we then take those bottles, rinse them, clean them, disinfect them, and then ultimately reuse them with another customer. And then actually, just for the sake of going down a tangent for a second, one of the big things to learn about kind of the plastic problem, and frankly, the greenhouse gas problem as well, is just the difference between types of plastics. And there's a whole kind of like set of literature that you can go out and read about number 2 versus number 3 versus HDPE versus PET plastics. But there's actually like huge differences as it relates to the types of plastics. So the majority of the stuff that frankly we're consuming, so like a water bottle, is intended for 1 or 2 uses at most, or 1 or 2 recyclings at most, versus there are more sustainable forms of plastics like that PET plastic or that HDPE plastic, where it can get 14, 15 recycles or reuses before ultimately needing to be disposed of or incinerated. And so there actually is huge differences between kind of the types of plastics that you're using. Can you see your company moving outside of Boston? Yes, absolutely. I would love to move outside of Boston. I would love to expand to Philly, New York, San Francisco, a whole bunch of different communities. And frankly, from a cost perspective, it's actually fairly minimal to have all of these kind of various outpost settings. And so I definitely see it in the near future, but I really want to kind of lock down Boston and try to kind of get Boston to as close to zero waste as we can prior to kind of going after new environments. Because at least in my belief, kind of creating that density of individuals who really care about a cause can be kind of more impactful than getting just a really small number in a bunch of different cities.
It also probably makes it convenient for your consumers to have lots of drop-off stations too.
Exactly.
Let me also just flip over to your website for a second, just to show people in case they want to take another look at this. It's good-filling.com, and they show you all the different, you can see they have these bottles of different things, and it shows you all how it works and everything like that. So if anyone's interested in taking a look at it, or if anyone, I don't know, there may be some people in the room from Boston or that end up moving to Boston after they graduate. So you might actually be able to have access to this.
And there's a whole bunch of more kind of literature and sources on that Redefine Clean, where it talks about the plastic issue, talks about our mission, talks about kind of the benefits of switching, but the why it matters is really talking about that plastic issue. It's correlated with this greenhouse gas issue, although it's not kind of a perfect one-to-one, but it talks about things like wish cycling, or talks about kind of the amount of plastics that are being dumped into our ocean, or the life cycle of plastic and how it breaks down over 450 years. And so more than anything, like listening to Michael's lecture and talking about how things are actually kind of exponential rather than linear sometimes, or that things that were at one point thrown out or ended up in a landfill actually break down over time and continue this issue of greenhouse gas production. It's super related to this plastic issue. Everything that's in landfills is breaking down over the next 450 years. So even if we get to zero waste, you will still see methane production in those kind of in those facilities and in those trash dumps, essentially.
Yep. All right. Well, as much as it would be fun to talk to Petros for a whole class, sadly, since this is our last day, I do want to get to a couple other things that I really want you to hear before the course is over. I don't know, Petros, if you want to, you can put your contact info into the chat if people have other questions for you. If not, that's also fine.
Sure.
And if anybody would like to learn more specifics about this, or if people are from Boston, like I was saying, and you want to learn literal specifics because of that, feel free. Okay, anyways, I don't have a lot of time left, but let me see if I can get through a little bit more material. Okay, we're gonna skip that. Remember, we were talking about personal stuff you can do to decrease your greenhouse gas emissions. Number one was reduced energy use. Number two was reducing the amount of material stuff that you used. Number three was reducing the carbon footprint of your diet. So just to say a few words about this, it is in fact true that a lot of meat products and animal products end up producing a lot of greenhouse gas emissions in where they come from and how they work and how they're produced. Something that you've been hearing a lot about kind of in the news over the last couple years is how bad beef is. That is true. Beef does tend to produce a lot more greenhouse gases than even other meats. Lamb is also quite bad, which is not so important in the US, but in a lot of places in the world, people eat a lot of lamb. And then in general, plant products have a much smaller greenhouse gas footprint. So what your vegan friend has been telling you about the environmental impact of animal production is in fact at least partly true. Greenhouse gases from animal agriculture are a significant problem. So, this could take the form of reducing the amount of meat that we eat. It could take the form of trying to become vegetarian or vegan. Or it could also, in terms of like more technologically, it could take the form of changing our animal agriculture of what animals we actually use, moving away from cows and lambs and shrimp and moving towards maybe things that have a lower greenhouse gas footprint, like chickens, or if we're being a little bit more novel, I've actually read a few articles about how the environmental impact of insect agriculture is actually incredibly low. So there's some people who want to move towards insects as one of our main protein sources in the future. I read an article a while ago about a case where they raise, I think it was maybe, what was it, crickets maybe, and then they grind them up into a powder, which is like protein powder, and you can use it in like baking, basically. The article, it was in Popular Science or Popular Mechanics, I think. They had that guy Duff from the that cake show on Food Network, and they had him make a cake with insect flour. You know, so I don't know if that's the way things will actually go, but that's another thing you could hear more about in the future. I think maybe I'll just flip through this section really quickly because it's just kind of another viewpoint on what I just talked about of where we actually use a lot of where we actually produce our greenhouse gas emissions. Not surprisingly, it's electricity, heat, agriculture, and industrial stuff primarily, and transportation, which is exactly what you would expect from what you probably already know and what I just said in the last section. One thing you will notice, though, is there's not one overwhelming source of greenhouse gas emissions. It's actually pretty even in terms of like, yes, electricity is a problem. Yes, agriculture is a problem. Yes, consumerism is a problem, and so on. So we need to solve all of these problems. And I'll just kind of leave it at that. I'm just going to flip through this just for the sake of time. Because the other thing I really wanted to get to is whenever you kind of get into the political dimension of this, there's a lot of discussion, like the question that I mentioned, someone asked me in the chat earlier about like which countries are to blame for global warming and which countries should have to do the most in solving global warming. And in the words of the IPCC, effective mitigation will not be achieved if individual agents advance their own interests independently. Cooperative responses, including international cooperation, are therefore required. So international cooperation is going to be key. So then that gets into this whole international issue of which countries are the biggest problem. I think I'm going to skip through this section here and start here. The short answer to that question of which countries are the biggest problem, the short answer is it kind of depends how you look at it. So I'm going to show you a few different ways of looking at it just to inform you about all the different ways that this is often presented that you might hear about. And people will frequently present whichever way of looking at it is the most favorable to their argument. But I think you should be aware of all the kind of different ways of looking at it. So number one is to do everything per capita, per person. If you do everything per person, the biggest problem is clearly the United States. The United States uses the most energy per person in the world. The United States produces the most greenhouse gases per person in the world. And you can see in that chart there, the US is way above everybody else in terms of carbon dioxide emissions per person. After the United States, the next category, they've grouped a bunch of countries together in this graph for whatever reason, but the next group that's in the light blue line is Japan, Russia, Canada, and Australia, which are all kind of major offenders. Europe is kind of in the middle as pretty bad, but they've been improving. And then China is right around the same level as Europe right now. China and Europe are about the same emissions per person, although Europe is kind of trending down and China is trending up. And India is still quite low per person. Question in the chat, when China implemented the National Sword Act in 2018, which banned all imported recyclables, I heard that the US resorted to burning most of our trash and recyclables because we didn't really have a decent functionable system of recycling and handling trash as a result of relying on China for over 30 years. How has the US dealt with this problem? That I have very little idea about. Do you know the answer to that, Petros, if you're still there?
Yeah, that is actually right. So China did stop accepting a ton of our recycling and trash, frankly. And again, this gets back to the complicated economies that kind of underlie or underpin the recycling community. And I do know that there was kind of a coalition of individuals from kind of the manufacturers of plastic bottles themselves to ultimately combat the issue and to start funding various facilities in the US to ultimately deal with it. If you look at the US in terms of actually being able to deal with the plastic issue kind of in-house compared to most European or frankly developing countries, we're far behind as it relates to that. And so I know there was a ton of investment. There was a couple funds and nonprofit funds that had raised kind of somewhere between 100 to 200 million dollars to ultimately develop some of the capabilities in-house. But even still, I think we're far behind. So definitely more to be done there. And frankly, would love to see from a political perspective, people getting more involved as it relates to combating that issue.
Thanks. So I mentioned on the previous slide there that if you do everything per person, the United States is clearly the worst in the world for greenhouse gas emissions. But then if you flip it and instead of doing everything per person, you start looking at totals, then China becomes number one. And that's because China is kind of in the middle in terms of emissions per person, but they also have a huge population. So a good, roughly correct kind of rule of thumb on this is that China's emissions are about double of the US emissions, but their per person emissions are about half because their population is about 4 times the US population. So, per person, the US is the biggest offender. Total, China is the biggest offender. Which of those is more important is really up to you. But you'll hear both of those being thrown around. So you have to be extremely careful when you encounter one of these facts of what exactly is this person saying. Are they using per person, per capita data, or are they using total data? Because it makes actually a huge difference in the story here. Also, India, if you're interested in India, India's per person emissions are very low. But again, because India has so many people, they're actually one of the tops in total emissions, although they're still way behind the United States, even in total emissions. The other thing to think about is the trends over time. Over the last couple of decades, Europe's emissions have been falling gradually but steadily. So they've been doing a decent job of decreasing emissions. US emissions have been, let's call it stable. They've been roughly unchanged or maybe slowly decreasing over the last couple of decades. China's emissions were going up very, very rapidly, and it was a huge concern about 10 years ago, but now they seem to have stabilized. So, the trends over time, paint a slightly different picture. But again, the current total emission picture, you can see a different viewpoint of it here. You have China and then the US at about half that level, and Europe a little bit below that, and India a little bit below Europe. The other way people sometimes present this, especially if they're coming from more of a perspective of whose fault is this, is to look at cumulative emissions. And again, so that means the total emissions that this country has ever emitted since the beginning of the Industrial Revolution, basically. Because again, in some sense, that's a fair way to look at it, because cumulative emissions are actually what causes warming. So the total that your country has ever emitted is actually how much your country is responsible for global warming, ethically speaking, I guess. And if you look at cumulative total emissions, the US is back to number one. Europe is now quite high in cumulative emissions because, of course, Europe was the beginning of the Industrial Revolution. So they started emitting first. So over the course of history, theirs are actually quite high. And China is a little bit below Europe. Still significant, but US becomes number one again, and Europe becomes more significant from this standpoint. So depending on how you look at it, clearly the United States is a problem. Clearly China is a problem. Those are the two that end up jumping out at you, no matter how you kind of twist around the data, as for the most part, the number one and number two. Which order you put them in of who is number one and who is number two can depend how you look at it, but it's pretty clear that the US and China are the number one and number two problems. Okay. Now, a lot of times, the reason why people spend a lot of time arguing about this particular topic is because what they're thinking is, we want to be able to blame global warming on somebody so that we can say, well, it's their responsibility to fix it. And that is a very kind of misguided way of looking at global warming, because the bottom line is, and this gets back to the question I was answering much earlier in the lecture today, the bottom line is, yes, maybe politically and ethically it matters whose fault global warming is, but if you're practically solution oriented about this, it kind of doesn't matter, because our goal, remember, is to get worldwide emissions to zero. So if you're asking the question, well, which countries should have to cut their emissions? That question I can answer. Everyone has to cut their emissions by 100%, is the bottom line. Whether that's economically feasible, I don't know. Whether that's ethically right, I don't know. But practically speaking, that is the solution to the problem. Everyone has to cut their emissions completely, no matter whether it's their fault or not, no matter whether, it's easy or hard for them. In the words of Richard Muller, to favor dropping carbon dioxide levels in the air while simultaneously arguing for no restraints on emissions from the developing world is inconsistent. Because just to stabilize greenhouse gas emissions, emerging economies must cut their emission intensity by 8 to 10% per year. That will be hard, probably impossible. So again, it's really everyone's problem, and everyone has to contribute to the solution, not because I'm making some kind of ethical argument, but just because that's the only solution to the problem, is that everyone has to cut their emissions down to zero ultimately. You can have some arguments, of course, about who maybe has to cut their emissions first, who has to cut their emissions faster, and so on. But the bottom line is everyone has to cut. Okay, I've only got a couple of minutes left, but I want to tell you what's happened over the last few years with China and the US, because we're kind of the two biggest problems. When it comes to China, their emissions were rising very, very rapidly from, let's call it 2000 to 2010 decade. And then around 2011, their emissions started to stabilize. And so their emissions now are about the same as what they were in 2013, 2012, like that kind of era. But remember, stabilizing emissions is not good enough. We have to cut emissions down to 100%. So stabilizing is only the first step. Now, the good news about China is that just over even the last couple of months, actually, there have been some significant developments with what China has promised to do in the future. In 2014, they agreed to basically stabilize their emissions, so that they promised that by 2030, they were going to guarantee that their emissions were not going to get any higher, and that 2030 would be the peak of their emissions before they actually started stabilizing and going down. And just actually a couple months ago, China suddenly announced that they had a plan to go to net zero emissions by 2060, which is great. That's fantastic news. Whether they're actually going to achieve that target or how they're going to achieve that target, I don't know. This is kind of hot off the presses news to some extent. I don't think anybody really knows exactly what their plan is of how they're going to achieve this. But if they can succeed in getting their emissions to net zero by 2060, that would be a huge step forward in actually trying to achieve a 2 degrees Celsius goal for the 21st century. because that would take a huge chunk out of global emissions. So great news there. And that's just happened in September. They announced that just a couple of months ago. So on the graph you're seeing right now, black is their emissions so far. These X's are like their kind of targets for the next few years. And then this red line would represent approximately how they would need to change that graph and turn it over in order to achieve this 2060 target. So we'll see how that goes. As far as the United States goes, what we had previously promised to do was a 25% cut in our emissions by 2025. And so our emissions have been gradually going down. Now, up until COVID happened, the rate that our emissions were actually being cut seemed like it was way too slow, and we had no chance of actually hitting the 2025 target that we had set. But actually, once you factor in the COVID dip, it actually seems like it might happen. So we may or may not actually achieve our emissions target for 2025, depending on whether things bounce back after COVID or whether we actually learn some lessons from COVID and keep some of the progress that's been made in locking people down in the pandemic. So this black line is how US emissions have changed over time. You can see the big dip at the end due to COVID, and there's where our target is, a little bit lower than where we are right now. Now, the other big news in this world is, of course, Joe Biden getting elected as the next president of the United States. To date, the United States does not have any target for getting to net zero emissions, although a number of different states and some big cities do have such targets. But if you look at Joe Biden's climate plan, he is promising to try to get the United States to net zero emissions by 2050, which again would be great news if we could achieve that target. So far, and not just because of the Trump presidency, but over the last 10 plus years, our progress has not really been that great. So we're definitely not on track right now to get to net zero emissions by 2050, but that is the claim that's in the Biden campaign platform. So we will see how it goes with that goal being met. Now, I will say, first I wanted to mention the Trump administration stance was very much of not cutting our greenhouse gas emissions. Trump actually pulled us out of our commitments that we had made to date in the Paris agreements, and was promoting very heavily coal as a return to coal energy, which is exactly the opposite of what we need to do to reduce our greenhouse gas emissions. So that was a big problem, although emissions did seem to continue to fall while he was president, in spite of his rhetoric. And then on the other hand, what will we see from Joe Biden? In my opinion, it's just too early to tell. There have been, it seems, an equal number of promising signs as confusing or negative signs in what's happened so far. I put some of the headlines that jumped out at me in the slide here. 1 minute, you have Joe Biden distancing himself from reducing greenhouse gas emissions. The next minute, you have him making very strong statements in favor of reducing greenhouse gas emissions. So I don't really quite know what to make of this yet. I'm not quite convinced yet, but we will see what happens over the next few years. And I will also say, I read his actually quite long and boring clean energy plan on his website. And it does contain the idea that we'll be cutting emissions by 2050. But what kind of jumped out at me when I was reading it is that the whole thing seems to be about economic stuff and creating jobs. And there's nothing really in there about reducing consumption. There's nothing in there about, reducing consumerism. There's nothing in there about maybe questioning the idea that constant economic growth might not be the way to achieve these targets. So I have some concerns for that reason. I actually went through, after reading this, and did a little Control F searching through the document just to try to put this in perspective for you. And what I found was that jobs were mentioned 61 times in his climate change plan, and unions were actually mentioned 32 times. The automotive industry was mentioned 21 times, but carbon was only mentioned 20 times. Climate change was only mentioned 9 times. Greenhouse gases were mentioned once, and there was no mention of consumption or reducing consumption at all anywhere in the plan. So it seems like his plan is mostly to try to use technology to switch us over to greenhouse gas free energy sources. And especially there's a ton of stuff in there about switching over to electric cars, basically, which is why there's so much talk about the automotive industry, of getting manufacturing of electric cars jump-started in the United States. But there doesn't really seem to be anything in there about addressing the root causes of greenhouse gas emissions, which concerns me. But it's too early to really form any strong opinion about that. But that's just what I saw from a quick analysis of his website. So anyway, I've gone over time, but that's the stuff I kind of just wanted to say for those who are interested in this topic and kind of wanted my analysis of what's going on. If you're interested, you can keep on reading here. There's more stuff in the PowerPoint presentation, but I shouldn't keep you forever. I've got to switch over to my 12:30 class. So thanks for joining me this whole semester. I hope you got something out of the class. And if you have any questions or need anything as we move forward towards preparing for the final, feel free to contact me. And I'll post some announcements on Canvas with some details about how the final exam is going to work and all that type of stuff.
Thank you.
Yep.
Thank you.
Yep. Thanks to all of you as well.